Hi everyone, my name is Tejumade Afonja.
Hi, my name is Clinton Batako.
Today we'll talk about our project titled SautiDB-Naija. The performance of voice control system is usually affected by the accent of the speaker, and this is mostly because it's being trained by data that are not as diverse as the target demographic. So there's need to enhance the accent comprehension of this system. Also, online learning has become more mainstream in the world. It means that a lot of students are now being exposed to different English accents for programs that are in English. And these programs are all mostly offered in institutions outside of Africa. So here is also another possibility for accent translation task to improve learning experience of students. To better understand the impact of accents on understanding, we conducted a survey a few months ago. We had about 374 respondents from over 38 countries. We asked if they think that the accents of the speaker influence the understanding of listeners, and about 70% said yes. We further asked them if they think it affects their ability to learn, and about 145 of the people that responded to our survey also said yes. We believe this is significant. So the discrepancy in accents often lead to listener comprehension, like a decrease in listener comprehension. It means that students would naturally focus on the accent of the instructor instead of on the content. So, the key question in our research that we're trying to answer is that, is it possible to develop a tool that can translate one accent to another without distorting the speech of the content of the speech? So we move on to talk about our speech collection process.
In order to achieve this, we had to build a web app to collect native Nigerian accented speech, given that there were no data sets that had this at the time. Data collection is still ongoing, but we were able to publish about 919 speech recordings of native speakers in 5 Nigerian accents: Yoruba, Igbo, and the rest. We chose sentences that were phonetically balanced, so we just opted for the CMU Arctic database, and then we built a web app to enable people to record. Our speech recordings were persistent as mono, 16-bit, and at 48 kilohertz. This is a representation of what the UI looks like, and most importantly, we collected the ethnicity of the speaker, and on the right, you have the test prompt. Majority of the speakers in our published data sets were Yoruba people, and also we had significant speakers from other ethnic groups. Minority ethnic groups were also covered. Now on to experimentation.
Yeah, so to validate our data set or to quantify the accent information in the corpus, we looked at a task, the accent classification task. So here, we want to see if we can have speaker independent embeddings where representation, speaker that speak the same accent are represented in the same space. For this, we looked at an encoder classifier model that consumes speech data. The encoder would output an accent embedding vector, which is passed to the linear classifier head, and then the classifier would output accent class probability. So this is an accent classification task. So for the Fixture Extractor part, we looked at MEL spectrogram and WAV2VEC. MEL spectrogram is a frequency domain representation of time series speech data. It's also handcrafted, so there's no need to fine-tune or train parameter rather. So, but the WAV2VEC is much more powerful. It's self-supervised pre-trained model. It encodes general information of input audio, but the downside here is that it had some compute overhead. For the 3 experiments we look at was that first of all, the base model, which is we just get a WAV2VEC model and try to train an accent classification task on it without fine-tuning on our fine-tuning the data, the weights. But then that is the base model. The other experiment we looked at is using the MEL spectrogram as our Fixture Extractor, and then also conducting the accent classification task. We looked at another task, which is that WAV2VEC, which is pre-trained on our model. So we fine-tuned this WAV2VEC on our model, on our data set rather. And the last experiment that performed the best in this setting is the WAV2VEC that is fine-tuned on our data plus batch normalization. But to get a sense of what this looks like in the embedding, we looked at the PCA. And as we had hoped this would happen, that the clusters, the accent that are close to each other would be clustered in the embedding space together. And we can see this, the Igbo speakers are clustered, we're all clustered together, as well as the other speakers. What might be much more interesting about this result is that it looks like geographically, speakers that are closer together geographically also seem to be close together in the embedded space. In conclusion, we present our SautiDB-Naija Corpus, which consists of 5 Nigerian languages to support tasks like accent classification and translation tasks. So we would be expanding our data significantly in the future, and we also would be commencing research on the accent translation task, which we hope can help us build a tool to translate from one accent to another, thereby improving online learning experience.